Introduction to Superelevation in Civil 3D, created by Ahmed Noor. Welcome to this lesson in Superelevation in Civil 3D. Superelevation is the banking of a roadway at a curve to contract the lateral acceleration experienced by vehicles. Proper superelevation improves safety, comfort, and vehicle stability. In this lesson, we will explore how Civil 3D allows you to define superelevation using design standards, tables, and formulas, and how to apply them efficiently to your alignments. About roadway design standards. Superelevation design in Civil 3D is based on roadway design standards stored in the design criteria file. These standards include minimum curve radius, transition length, and superelevation attainment methods. Using the superelevation wizard, you can specify the superelevation attainment method to set minimum curve radius and transition length values and apply project-specific standards to your alignment. The design criteria file is XML-based and stores standard tables and formulas for calculating superelevation rates and critical stations along a curve. You can customize this file to reflect local design standards using Design Criteria Editor. Superelevation rate tables. Superelevation rate tables define the banking percentage for different curves. They depend on curve radius. Tighter curves require higher banking. Design speed. Faster speed require greater superelevation to maintain safety. These tables allow Civil 3D to automatically calculate the full superelevation rate for each curve in your alignment. Transition length tables. Transition length tables determine the distances between the critical superelevation points along a curve. These tables define how quickly the road slopes from normal crown to full superelevation. For example, level crown to full superelevation, LC to FS, defines the runoff distance. Normal crown to level crown, NC to LC, defines the tangent runout. Using these tables ensures smooth superelevation transition and compliance with distance standards. Superelevation attainment methods. Civil 3D support two superelevation attainment methods. Standard method removes adverse crown, typically used for undivide, crowned roadways, and divided roadways with planar or crowned sections. 2. Planar method doesn't remove adverse crown, used for undivided planar section roadways, ramps, or surface roads. Choosing the correct method is critical for accurate superelevation computation and smooth transitions. Superelevation variable and formulas. Civil 3D calculates superelevation transition using variables. E equal full superelevation rate from the rate tables based on the speed and radius. T transition length from the table may represent runoff distance or rate. C normal lane slope positive. S normal shoulder slope positive. W lane width. L spiral length in the curve group. P fraction of transition before start or after end of the curve. Q rate of acceleration increase along the curve. These variables are used in the formulas to calculate distance for level crown to full superelevation, level crown beginning of the curve, normal crown to level crown, and level crown to reverse crown, and normal shoulder to normal crown. Previous table are used to calculate the following: normal crown, level crown, reverse crown, and full superelevation. Superelevation axis of rotation pivot methods. Civil 3D calculate the axis of rotation only within the superelevation curve group. Pivot points determine how lanes, shoulders, and medians rotate around the roadway. Each cross-section shows the pivot behavior at critical stations. Right-hand curves are typically illustrated with colored lines indicate lane rotation. Understanding pivot methods helps ensure correct lane and shoulder slopes along curves, particularly for complex roadway designs. Mastering super elevation in Civil 3D ensures safe, comfortable, and standards compliant roadway designs. Thank you for watching. See you in next lesson.